Good morning, everyone. I request to Dr. JP or sir, please introduce today's speaker and start the session.
Thank you, Hamidaji. Uh, Welcome all. A very good morning to all of the participants and the speaker, our resource person, Dr. Jitendra Kumar. As his introduction goes, he has started his service career as an assistant engineer in Panchayati Raj Department, Rajasthan, and worked there from 2007 to 2009 for a period of 2 years. After that, he joined as a lecturer in a government polytechnic institution, that is Jawaharlal Nehru Polytechnic, Mahmudabad, Sitapur, which comes under the Board of Technical Education, Uttar Pradesh. He has worked as an assistant professor in the Department of Agricultural Engineering at Janta Mahavidyalaya Ajit Mal Auraiya, which is affiliated to Chhatrapati Shivaji Maharaj University, Kanpur. He served this institution from 2017 to 2020 for 3 years, approximately. Presently, he is working as an assistant professor stage 2 in the Department of Agricultural Engineering, CSSS PG College Meerut under CCS University, Meerut from January 2020. Dr. Kumar did his BTech in Agricultural Engineering from Chandrasekhar Azad University of Agriculture and Technology, Kanpur, and MTech in the same discipline with the specialization in Soil and Water Conservation Engineering from Maharana Pratap University of Agriculture and Technology, Udaipur, Rajasthan. During his MTech program, he has been a recipient of GATE Fellowship. Dr. Kumar is a recipient of 2 awards, that is Engineer Musaddilal Memorial Award 2015 for Best Research, which was given by Institution of Engineers, Chapter, Lucknow, Uttar Pradesh, and second award is Best Teacher Award 2021 for Teaching Excellency. He has organized many scientific events, delivered more than 10 invited talks as resource person and guest lectures as subject expert. Dr. Kumar has so far published 2 book chapters, 20 research papers, and more than 10 popular articles to his credit in various journals of international and national repute. He has guided several students of BTech, MTech, and MSc Agriculture. Presently, Dr. Kumar is engaged in teaching and research on soil and water conservation engineering. So, with this brief introduction, I request Dr. Kumar to please go through his deliberation. Dr. Kumar, please.
Thank you, sir. Very good morning to all of you. I welcome all of you participants in this session and in this training of 21 days trainings, namely at recent advances in agriculture and technology for doubling the income of farmers. In this session, I am going to present a on the topic of approaches to control the soil erosions.
I'm not being able to see the presentation. Is it visible to all? Hamida ji? Yes, it's okay now. Keep it on full screen, sir, and start.
No. Is it visible to all or not?
Yes. Now it's okay. Perfectly okay. Make it on slideshow mode.
Okay. Thank you. Today, the project of this session of this topic is the introduction to soil erosion, importance of soil erosion control measures, types of soil erosion, forms of soil erosion, classes, factors, symptoms of the soil erosions. After that, we will discuss the mechanism of soil erosions and all these things, whatever get by wind or water, how will control these things will control by the soil conservation measures. And after that, we will conclude that if we apply the soil conservation measures in the field, and what will be the benefit to the farmers. First of all, I would to tell about the soil erosion. Soil erosion, it is a eroder that means to excavate. Three-phase phenomena, that means detachment, transportation, and deposition. Deposition is the last phenomena. Soil particles detached by the erosive agents, that is water and wind, and these detached particles transport through the erosive agents, same water and wind, and when the energy settle down, these particles is deposited. These three phenomena completed the soil erosion. This is a picture of soil erosion phenomena. This is the soil surface. Soil surface get raindrops on the soil surface. After raining, soil gets saturated. After infiltration, seepage and percolation. Then seepage infiltration cycle is completed, soil gets saturated. Then, once raindrop is strike on the soil surface, soil particle will be dispersed in the atmosphere, and these dispersed particles will be transported by the water, and these particles will transport their original surface process, which can be elaborated by the three-phase phenomena of the soil erosion. Now, why the prevention of the soil erosion is important for farmers? As we all of you know, the soil erosion is a concern not only for its impact on the plant growth, but also issue of water quality. We know soil is a valuable natural resource that nourishes, support plants growth, among many things. Many of let's bears exposed wind and waters can erode it. So though the main things that erode the soil is the left out of the soil bed and exposed. Soil erosions remove the top soils, which contains the essential components of the nutrients, which is necessary for plant, growth. So for plant growth, it is necessary to maintain the nutritive value of the soil, and it is harassed and removed by the only and only by soil erosion. So we have to maintain the nutrition value by controlling the soil erosion. Why soil erosion is so important? We have discussed to maintain the nutritive value and regulate the water flows, and to maintain the ecosystem, wildlife, etc. and etc. What are the measures caused by soil erosion? What will be the problem faced if a field, if a watershed gets eroded? The first problem that is eroded, soil gets the damage to the sea coast. You can see in the coastal areas, if you go to the Goa, you can see the beaches, and near the beaches, you can see the damage of the coast of the beach due to that. That's coming to stream bank erosions, waterway erection, formation of sand dunes. Formation of sand dunes is due to erosive agents of the wind. From one place to another place, finer particles get eroded by the air and collected to another place. The problem is the disease and public health hazards. As no water is stored, it is most of the probability that water is stored in a depressed place. If we see that soil is get depressed, and that depressed place, water, it will be stagnant for a long time. It will generate the disease like malaria, etc. and it will be very harmful to the public health, which create health hazards or this disease may be spread at broadly. Next problems may be spent of money on water purification works, then soil particles eroded and these particles transport from pollutes the water, and this water cannot be used for domestic and industrial purpose. So we need to purify this water for the domestic and industrial purpose, and needs of money for purification for it. Chepi sir, I am audible? Hello?
Yes, very much
Hello?
audible. Yes. very much audible. It's
Okay.
it's it's
Okay.
very
Thank you.
okay.
Okay. Thank you, sir. Thank you. Then next is the siltation of irrigation channels and reservoirs. Then these sediment loads, when it is transported from one place to another places, will be settled down in the channels or reservoirs, and will reduce the capacity of the channels, reservoirs, and rivers also. This may result in future is the flood or some many more hazards also. The next causes problem in crop irrigation considered need to conserve the waters. When we will irrigate by eroded waters, and so many sediments are, so many debris are mixed with this waters, so we cannot use this water. We need to conserve this waters for the irrigation. In a depressed system, the water for a long time, the problem will get shortage, and there is no addition to the soil and plants slowly down. That's why, as I have already told that the uppermost layer, which has the nutrient values, will be removed through the erosion, which results in fertile loss, fertility of the soil. Then degradation of the soil, the grade of the soil will be degraded and will be divided into many parts, and it will be fractured in several parts. That's problems that creates the problem for implement operations. This is wildlife. So many animals are living in forest watersheds. If these watersheds is divided in the vines and trees, then the so many shelters of animals will be disturbed and destroyed. And this is why the wildlife animals will also be affected. All these things, when erosive agent is thinned, it suspended form of atmosphere, which will disturb to the ecosystem. Also, these are the main causes by the soil erosion. However, these are the main causes of the soil erosion. The main impacts of the erosion, which is related directly to the farmers, reduced stability of the soil, expose the physical and chemical properties, infiltration, etc., will be gets down, and runoff will be created very soon. Soil will be gets compacted. Higher runoff rates, which may result for floods, and the growth of the crop will get affected, and newly crops will also get lost. The silts will also laying down in the lowest areas. Now, types of erosion. There are two types of erosions. First one is geological erosion, and second one is accelerated erosion. Geological erosion is also called natural erosion because in geological erosions, erosion of the soil is completely equilibrium with the formation of the soil. There is an equilibrium condition in the geological erosion. It means the deterioration of the soil, erosion of the soil is equal to the formation of the soils. Geological erosion is a natural process. It is a long time process. It is normally just seen to be, since it is a long time process, it is cannot be visible in short durations. We can conclude geological erosion that the formation and deterioration of soil goes simultaneously, and we cannot observe that place it is not eroded if we calculate the geologic erosions. Then second one is accelerated erosion. Accelerated erosions is done or soil is eroded in acceleration is by the action of nature, human beings, animals. In accelerated erosion, there is no formation of soil during the deterioration of the soil. During the deterioration or erosion of the soils, It's a continuous process. Accelerated erosions further can be subclassified into two groups, that is water erosion and wind erosion. Water erosion, it is the removal of the soil particles by virtue of wind, and wind erosion is the removal of sort of the soil particles, detachment of soil particles from one place to another place by virtue of wind. Next, types of water erosions. Further, water erosion can be classified into 5 groups, that is displace or raindrop erosion, sheet erosion, rail erosion, gully erosion, and stream bank erosion. First of all, we will discuss the displace and the raindrop erosion. You can see the picture of the displace or raindrop erosions. It is also a picture of the displace or raindrop erosions. This is a clear-cut picture of the raindrop erosions. You can see here, these are the raindrops. When rain is falling on the soil surface, water will be infiltrated through the soil surface into the subsurface. After some time, soil will be get saturated and water will be flow as in the form of runoff on the surface of the soil. Before when water will flow, raindrops strikes on the soil surface. When raindrops strikes on the soil surface, then water will be dispersed due to the kinetic energy. And these detached particles will quickly transferred will be erode the soils. This was the space or rain of erosion. And as the removal of the uppermost layer of the soil by the action of water.
Just a little interruption, doctor. Just a little
Okay,
interruption.
right,
Your bandwidth seems to be slow,
okay,
and your
okay.
network is also low. So if you,
Yes, yes.
I suggest if you please turn off your video, it might be little better. And please keep yourself closer to your microphone so that the voice that is breaking or that is the volume is lower, that can be optimized.
Okay.
Okay.
Okay. Okay. I'm off my video. Is it fine now, sir?
Yes, it's
Is
pretty
it fine?
fine now. It's better, much better than before.
Okay.
Okay.
And next one is the city road. Practically we can see this is a field, and after the rainfall is stopped, the raindrops, as I have already told you, that the raindrops particles from one place to another places, and raining is continue, then almost the areas get affected by the raindrops, and these all particles dispersed by zigzag and and fro. Then it is removed from the land. Next one is the rail erosion. Rail erosion is a formation of small soil surface. You can see rail erosion is you can see if you go to the field, you can see the small ridge is made in the field with the rail erosions. Next is the gully erosion. Gully erosion is the advanced stage of the rail erosion. When rain is continuing and erosion is also continue, then these rills gets the enlarged shape. Enlarged shapes gets in the gully, and this is the gully erosions. These gullies are forming in the field. You can see these are the gullies which is formed in a barren land. This is a barren field. Next one is the stream bank erosion. Stream bank erosion is the scoring of the bank of any rivers, reservoirs, ponds by the action of the sediments loads or water loads. It's basically stream bank erosion gets by the action of the scoring. You can see is the stream bank erosion. Banks of the water structures get eroded by the scoring action. These all types of erosions, which I have already discussed, that the rain is coming on the soil surface, soil gets saturated, then soil particles get detached due to the kinetic energy of the raindrops, and these stress erosion containing removal of soil is this is the sheet erosion. Then small ridges will be formed in the soil surface, and containing these rills will become enlarged and a gully erosion will be obtained. And these all the sediment flows, water flows will go to a depressed points that may be the river channels, reservoirs. Here, these loads will be flow with the runoff and will take a scoring actions and create the stream bank erosions also in channels, rivers, reservoirs also. There is a sheet erosion's intensity, which indicates that how much intensity of sheet of erosion. In case of sheet erosions, we can say that this is the slight erosion or moderate erosions. We can say the less than 0.5 meter cube per hectare per year erosion intensity. Then we can say that there is no erosion, insignificant erosion. We should worry when erosion gets 0.5 to 5 meter cube per hectare per year erosion intensity. We should worry, and then we should take the actions regarding primary treatments of the erosions. The erosions we can also recognize by picture. We can recognize by data also. The gullies further classified very small gullies, medium gullies, deep, narrow gullies. However, gullies may be the basis of the activeness, that active gully or inactive gully. Active gullies continue eroded or enlarged in future also. But inactive gullies, if they get eroded and get a shape, in future they will not get eroded. Further, on the basis of the shape, we can also classify the gully erosion, U-shaped gully, V-shaped gully. U-shaped gully is large in size, V-shaped gully is small in size and have a high flow velocity. Here is the symbol of G1, G2, G3, G4, which indicates that the very small gullies, medium gullies, deep gullies, up to 3.
Hello, Dr. Kumar. I think he has lost his connectivity. Hello. 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 Dr. Saab, it seems that you lost your connectivity. Can you reconnect, please? Okay. Okay. We are waiting. Very soon he is going to reconnect with us. So Let's wait. Please bear with us. It's the system failure that has caused our speaker uh, disconnect. Yes, yes. Welcome, doctor. Please, please. Hello. You are not audible. You have muted yourself. Please unmute. Let me see if you could not unmute yourself.
Yes, yes.
Okay, okay.
I'm audible now. Okay.
Yeah, yeah, yeah. Now
Okay.
you can
I'm showing
start.
the screen. Okay.
Yeah. Please keep yourself as close to the microphone of your system
Right, sir.
as you
Right.
can,
Okay.
because volume is very low.
Actually, it is all by low server.
Yeah, yeah, yeah. It's it is the
Sorry, sir,
system that
for
is
this
harassing us.
interruption and for inconvenience.
No problem, no problem.
Okay.
Participants are there. All ears to listen to you.
I'm starting the PPT on mobile also.
Participants will be getting the PPT, sir. You
Okay,
can
sir.
present your lecture
Okay.
because they will be given the
Right.
PPT. All the PowerPoint presentations they will be given. You can continue
Okay,
speaking.
right. Okay. Then I
Okay.
elaborate the statements that indicates the area affected by the erosions, and these are the Andhra Pradesh, Gujarat, Maharashtra, Madhya Pradesh,
So please show your
and
presentation. So your presentation is not visible.
okay, right. Just is it visible now? Is it visible
No,
now?
sir. No, sir. No, sir.
Okay, I'm sharing the screen.
Please continue, please.
Right, sir. I'm sharing the screen. Now, these are the other forms of erosions. Tunnel erosions, river erosions. Listen erosions is basically the large species of the ice which erode. So, snow erosions, when long times of the snow is falling and they erode the soils, organic erosions are is due to the living organism anthropogenic by the human beings, and compensating erosion is the deterioration and formation of the soil continuously, simultaneously. Erosion is by scoring tanks and scoring of the erosion. Is it audible? Is it audible, sir?
Yes, yes, yes.
So,
But
yes, sir.
voice is breaking a lot.
But still,
So actually, you don't
still
have a good internet connection. It is because of your slow
right.
internet connection. So please stop sharing and just speak.
Okay, okay. Can you show the slides from your side?
JP sir, do you have a sir's presentation?
Can you send?
S-
I'm sending, sir.
Hello,
That's sir.
is it
Right,
okay?
G. Right, sir?
Yes, sir. Yes, sir.
Okay, okay, okay.
Okay. Okay, ma'am, please go to next slide, please.
So
Go to the slide number 32.
Please guide me.
Please go to the slide number 32. Yes, this one, ma'am, this one, please. Please go back. One more, go back. Right, right. That's fine. Next, please. Next, please. Yes, this is the classes of the erosion. We can further classified in the class first, second, third, fourth erosions. In the class first erosions, the A horizon gets affected by 25%, and in class second erosions, A horizons gets 75 eroded and maybe eroded by underlying layers. In class third erosions, A erosion gets completely eroded, and some portions of the B erosion also gets eroded. In class 4 erosion gets by removal of the complete removal of the erosions we also. In the same way, class 1, class 2, class 3 erosions are gets affected. But in class 1, complete removal of the erosions gets obtained. In fact, in class 2, the removal of A horizons and B also gets removed. And in class factors affecting, next please, next please, yes. Now factors affecting the water erosion. What are the factors that affects the water erosion? That is the climatic factor, soil characteristics, humidity are the main components. If rainfall intensity to ocean and rainfall intensity is greater than the infiltration rate of the soil, then soil will get eroded and soil and the runoff will be created on the surface of the soil. and soil will be get easily eroded. If the infiltration rate of the soil is high, then the rainfall intensity, how your rain is uh, going for, rain is raining for 1 hour, 2 hours, 3 hours, there is no soil erosion. If there is no runoff, if the rainfall intensity is less than the soil infiltration rate. However, temperatures also a factor, humidity also a factor, since the transpiration and evaporation also gets affected by the temperature and humidity. But these are the minimum factor, but the main significant factor are the rainfall intensity and duration of the rainfall. Next one is the soil characteristics. Soil is single grain soil, is honeycomb soil, it is a double honeycomb soil. These types of single grain soil is mostly gets affected by the soil by extracting the raindrops. Third one is the vegetation. If the soil is have no crop cover, it have no no cover of any shrubs, bushes, grasses, etc., then it will be easily gets affected and it will be eroded easily. If a soil has any type of cover, the kinetic energy of raindrop will be dissipated and soil will be gets eroded very slowly or slowly, and the effect of the raindrop will be very less. Then topographic factors, topographic factor the slope of the soils. If a soil has the high slopes or moderate slope, it will this type of soil will be gets eroded easily. A clean soils will not get eroded. Next slide, please, then. Yes. This is the effect of the slopeland on soil erosion. You can see at the left it is the plain land, flatlands, and right side is the slopelands. Slopelands get easily eroded and particles will transport very fast from one place to another place. We can see like pictures. Next, please. Next, please. Next, please. Yes. This is the effect of soil cover on the soil erosions. You can see that 411s are vegetation factors. In this picture, you can see left side, this is uncovered soil under rainfall, and this is the covered soil under rainfall. Covered soils is not get affected by the raindrop energy, and it is not eroded by raindrops. So you can see and observe that the importance of the covered on soils. The please, next please. Then the factor bring these factors. Next please. These are the tabular form of. This is the tabular form when we can see the rainfall intensity. Rainfall intensity is low. Rainfall intensity, rainfall volume is low. Wind resistance is low. Relief is low. Gentle slope is low. Then soil erosion will be low. If rainfall intensity is high, runoff volume is high, wind strength is high, relief is high, gentle and slope angle is high, steep, then erosion will be high. Next, please. This is these are the symptoms of the water erosions. If you go to the field, then you can see the symptoms of the water erosion. If gullies enlarge, there is a spot of rills on the field, and netting of the plants, tips of the soils, and debris, and at the and light colors and change of the natural plants also, siltation of some reservoirs at the depletion points, etc. etc. Next, please. Next, please. This is the mechanics of the water erosion. Mechanics is involves the 7 steps of water erosion. First steps of water erosion is the hydraulic action. When rain comes on the soil surface, it's get saturated. But before saturation,
Can we quickly move? Can we quickly move to the control measures, because we have very limited time? only 10 minutes.
Okay,
So,
okay, sir. Okay,
if you
I'm
permit.
moving fast. Okay, I'm moving fast, sir. I'm moving fast. This, as when soil gets saturated, there is a presence of this air, and when soil gets saturated, air will be desaturated, and this pressure of the air will disperse the soil particles and detach the soil particles, and will result the soil erosion. Next, the abrasion is detached particle will mix with the water and score the soil surface. Third one is the attrition. Attrition is the mixture of the rocks, and these rocks which flows with water will be flexed, will be break down in small particles and erode the soils. Then solution is the mixture of some chemicals and will erode the soils. Then after these fourth one are the these fourth one are the which erode the soils, and these eroded particles they are transported by wind or water action, and then deposited in some place by deposition. Next, please. A. A. Next, please. Next, please, then. Let's go back. Please come to this slide. Mechanics of the right. Okay. These are the soil conservation research and training centers. First 8 are the research and training centers which conducted the study related to the soil conservation and which solves the problem of the soil erosion in different areas. Jodhpur, Hazaribagh, and Hyderabad also deals these problems. Next, please. These are the approaches to soil conservation. There are 3 approaches to of soil conservation for control of the soil erosion. That first one is the agronomic approach, second one is the soil management, and third one is the mechanical approach. Agronomic approach includes yes, the soil conservation strategies for the cultivated land. Cultivated lands. In cultivated lands, agronomic measures, soil management, and mechanical methods. You can see the agronomic measures, mulching and crop management. Mulching is there is 2 types of mulching: natural and synthetic. Natural mulching maybe by the organic matter, synthetic maybe by the artificial methods. Then second is the agronomic measure is the crop management. Crop management includes the 3 phases that are high density planting and multiple cropping and cover cropping. Multiple cropping, the crop rotations, and the strip croppings. Then cultivated and soil management should be like this conservation pillage, where pillage the soil, up and down slopes, always delays the soil, throws the slope across the slopes, and contour delays, raising and tying minimum delays can be used in the soil management practices, which may help for control of soil erosion. In mechanical methods, terracing structures and waterways may be used. Next, please. In the same way, agronomic and soil management mechanical measures can be used. Since this is the non-cultivated land, and here is the non-cultivated land is the grazing lands and the forest lands also included. So, for improvement and control of the soil erosion, grazing and forest lands, we must do the plantings and agroforestation, planting the grasses and shrubs, even other things also. In the same way, mechanical structures as in cultivated land use, we can use the same structures in the non-cultivated land also. Next, please. This is the contour farming as a strip cropping, which is the example of strip cropping, narrow growing and erosion resistance of growing in strip cropping. Next, please. Next, please. Strip cropping is next. Then these are the check dams for, I have already told that the structures, there are 2 types of the check dams, temporary check dams and permanent check dams. In temporary check dams, there are 2 types of temporary and semi-permanent, one way or 2-way dams. Please, next slide, please. Next slide, yes. This is the single rope to suit check dams. You can see this is the shape of the gully, then first of all we should develop this gully bit in the V shape, and then insert a trench of 15 centimeter, then insert the wooden post, flow the width in the subsurface up to a depth of 75 centimeter. The dia of the wooden post should be 10 centimeter at least, and the distance between one post to another post should be 90 to 120 centimeter, and the side slope of these gullies should be 1:1. Next, please. In the same way, double row brushwood check dams can be used. Double row is just similar to the single row, but the difference is that one more wooden post also inserted between the two posts. Next, please. This is the rock fill dam, and this is in the width of the gully. We should place the 60 centimeter depth of the stones. After that, fill the stones on gully width and wrapped by the wires. Next, please. This is the netting dam. In the netting dam, gully pad will be inserted by the wooden post, and this wooden post will be woven by the wire. And these woven wires will get the sediments from the head of the gully, and these old sediments will be deposited near or back of this netting dam. Next, please. This is the location of gully control structures. There are three types of gully control structures which is commonly used. That is chute spillway, drop spillway, drop inlet spillway. In the beginning, at the point of the head of the gully, there is so steep slope. We should the chute spillway at the steep slopes. If the gully head is level, then we can use the drop spillway. If the slope of the gully is medium, then we should use the drop inlet spillway. Drop inlet spillway can be used as a storage structure also, water storage structure also. Next, please. This is the slope of spillway, and in local language, it is called some other names also. If you go to Rajasthan, its name is Anicut. You can see the parts of these structures: head wall extension, side wall, apron, longitudinal inches. Every part at its role. Head walls retains the power or retains the forces of flowing waters. Also retains the maximum load of the flowing water. Head wall extension is made. Side wall extension is also used to store of the gully bed. And after that, apron is used to dissipate the energy of flowing waters. Inches also dissipate the energy. Longitudinal since is formed at a 45-degree angle, which retains the flowing waters into gully beds. So head, this structure is very important. Next one, please. Next, please. These are drop inlet spillway structures. Drop inlet spillways has the inlet, outlet, conduit, and earthen dams. And these structures dispose the safely water from one place to another place. Next one, please. Next one, please. Next one, please. This is the chute spillway. It is also has the part inlet, outlet, and conduit. By through the conduit, water is disposed to the outlet, and this outlet drain the water into water base. Next, please. This is the picture of the contour one. Contour one is water harvesting structures can be used as a water harvesting. Even is mostly used for the erosion control in the field. The contour fund is normally used where if the rainfall is less than 600 mm and slope less than 6%. Next, please. These are the picture of contour bunds. You can see the contour bunds is formed on the field. Next, please. Next, please. This is also the picture of the contour bund, and this is the plantations. You can see where plant is grown. Plant is grown nearby the bunds, and after some times, these down areas will be filled by upper portion land, and it after some time it will get be flat or level. Next, please. This is the contour bunding. Next, please. Next, please. This is the contour and gradient bunding. The difference between the contour and gradient bunding, contours may always made along the contour, but across the slope. And the same way, gradient bunding also we done the same way gradient bunding also. But the grade in a bund is also used normally. 0.3 to 6% grade is used in the bunds. Next, please. This is the terrace we can use for erosion control and storage of the water also. You can see the cut and fill of the soil. At the fill of the soil place, we develop a soil bunds. After some time, soil will be get leveled. Next, please. This is the urban masonry tank for control of soil erosion. Next is waterways. Waterways is a structures which used to control the soil erosion. It's used to drain the water safely. There are three types of waterways. The first one is trapezoidal, second one is parabolic, and third one is triangular. These the parameters of these three waterways can be determined by using these formulas. The main important thing is the waterways. Next, please. Next, please. Next, please. Next, yes, please. The main things in waterways is that the permissible velocity. There is a grass cover on the waterways that may be sparse, that may be gold, that may be sword or excellent grass cover. If a waterways has a sparse grass cover, that the permissible velocity must be 0.9 to 1.2 meter per second. If the permissible velocity has more than these data, then soil will be gets eroded. So in the same way, good grass cover should have the permissible velocity 1.5 to 1.8, and soil and excellent cover must be 2 to 2.5 meter per second. Next, please. This is stream bank erosion control measures, where the stream bank we makes a ball of grasses, and these balls of the grasses must be covered by a drape or a mat, and then these matted balls must be nailed by a wooden post, which will retain the erosion of the pipe. Next, please. This is the repavement. Repavement of the stream banks by using the stones. We can repave the bank of any river, channels, reservoirs, which reduce the soil erosion. Now, control of the wind erosions. For control of the wind erosions, we can use the shelter belts and wind breaks. The wind breaks normally used for up to 2 rows for the up to the wind velocity of 40 kilometers per hour, and it's used normally as a boundary of the field. But shelter belts is used in more than 2 or 3 rows and used with a high wind velocity. These shelter belts always put at the right angle or perpendicular to the prevailing direction wind. Finally, I will conclude that if we adopt these measures, then soil quality will be improved, soil will reduce the erosions, reduce the siltations, infiltration will be in. Next, please. Next, please. Next, please. Next. This I have discussed that these are the shelter belts. Next, please. Go to the conclusions. Yes, these are the conclusions that if we adopt the agronomic soil management and mechanical measures to control the soil erosions, after that we can see that the soil quality will be improved, productivity will be improved, soil erosion will be reduced, siltation of the rivers, reservoirs will get down. Infiltration of the soil will be improved, which will help in which will help to down the runoff, which will result to down the flood possibilities, and it will improve the air and water qualities also, provides food and shelter for wildlife, improves the soil fertility, crop yield will also be increased, soil condition also will be improved, moisture in the soil will be remain constant, section will not be done, and nutrition value will be maintained. Low water requirement will be for cropping purpose. Health hazards will be reduced, and irrigation efficiency will be increased. Ecosystem also gets improved. Next, please. Thank you. Thank you, everyone. It's completed, sir.
Thank you, Dr. Kumar. Thank you for a very impressive talk on approaches to soil.
Thank you, sir. But sorry for the inconvenience for the interruption of the internet. It was
Yes,
not a good
sometimes
delivery due to the interruption of the network.
Yes. This is common. This is unpredictable. Any system can be useless, but still we got. I think we have got most of the part of your presentation, and participants have been benefited from this information. So, on the behalf of organizers, on behalf of Banaras Hindu University, on behalf of participants, I thank you very much for your time and effort to address our participants and benefit them with your knowledge. So, thank you very much, sir. Thank you, participants.
Thank you, sir. Thank you so much. Thank you, sir.
Thank you, participants, for your patient listening. Any questions if there? All are unmuted. Hamida ji. Hamida ji, are you listening to me? Participant, if you don't find your option to unmute yourself, please send your questions in the chat box. We are here for a while. If there is any question. No questions? If you cannot unmute yourself, please ask the question in chat box. Our resource person is here for a while. He can answer the questions and we can discuss it. No questions? Still no questions. So, thank you, doctor, for
thank you so much, sir.
Information, and hope to have some
again feel a big sorry for this inconvenience and due to the interruptions.
You must not be sorry.
So
it's fault of the system. It can be anywhere. It is pretty unpredictable.
Thank you so much, sir.
Okay, then thank you.
Thank you.
Everyone can leave.
Okay,
Everyone can leave now.
leaving.
Okay.